Hello everyone. In this video, I'm going to go over some questions about the standard normal distribution. So at the top here, I gave you a couple of useful formulas. This is the formula for the z-score from a data value, the mean, and the standard deviation. And then this is the one that reverses that formula to let you get the data value from the mean, the standard deviation, and the z-score. So first, we'll just practice with using the standard normal table of areas a little bit, or the cumulative distribution function. So we want the shaded area under the standard normal curve. That's the bell curve here. So we want, in this one, the area to the left of the z-score of negative 0.85. So I am going to go to my standard normal table, and I'm going to look up that z-score. And what I'm doing is I'm getting the cumulative distribution function for that z-score. So this is function notation here. CDF is the name of the function whose values are actually on that table. All right. So we're going to use this table to look up the z-score of negative 0.85. So I'm on the negative side of the table, which means the values here under z are negative. So first I'm going to go to the one that starts with the right digits. So I have negative 0.85. So I'm going to go here to negative 0.8. Okay. And I'm going to look at this row right here. And then my second decimal place, the 100th decimal place, I'm going to refer to the top up here. So the one that is for 0.05, because I have negative 0.85. Okay, so I'm in this column right here. And so that is giving me this one right here, 0.1977. So 0.1977, 1977. Okay, so that is in fact the area under the curve to the left of this z-score. So that represents a percentage of 19.77%. That is the percentage of the area under the curve that is shaded right here. Okay, now let's do the one that is between two z values. So we have z1 and z2. So now we need to look up both CDF values, both areas to the left of these z-scores. So we're going to look up the value for negative 1.1, and then we're going to look up the value for 0.55. All right, so let's do the negative 1.1. Was it 10? Yeah, 10. So negative 1.10 right here is this row, and then the second decimal place was 0. Okay, so that is going to be this one on the end here, 0.1357. Okay, and then for 0.55, we're going to turn to the positive side of the chart. Okay, so we're doing, I already forgot what it is, 0.55. Okay, so I'm going to start with 0.5, and then I'm going to go to here, because this is where the column for 0.05 is, so it's this last one here, 0.7088. Okay, so those are the two areas. So the first one is the area to the left of this first z-score here. So it's this white area on the left, this left tail. And then the second one is all of the area to the left of the second z-score. So it's not only this blue area that we want, but it's also this white area over here. And then what we're going to do is we're just going to do the larger one minus the smaller one. So you kind of imagine that you start with more area than you want. So everything to the left of this vertical line here. And then we're like trimming off this shorter tail over here, everything to the left of this z-score. And that's going to leave us the area between those two z-scores. Okay, so lastly, we're going to do the larger one minus the smaller one. So I'm going to do 0.7088 minus 0.1357. Put that in a calculator. And we get 0.5731. Okay, for the third one here, we are doing a right tail. So we want the area that is greater than this z-score. Now our table, there's different versions of this table, but our particular table, you can see from the picture here, it does left tails. This is also a picture of a left tail. Left tails. Okay, so I only know from the table what the area of this white part is. But I also know that the area under the whole curve is 1. So what I'm going to do to get the opposite area is do 1 minus this white area that I don't want. Okay, so I'm going to look up the table value for 1.35 for my z-score. Okay, so 1.35, I need to go to the positive side. Start at 1.3 and then go to 0.5 for my second decimal place up here. Okay, so it's going to be 0.9115. All right, and then that is actually this white area here, the left tail, and I want the right tail. So I'm going to do 1 minus that. So 1 minus 0.9115 and get my calculator and actually subtract. And I'm getting 0.0885, about almost 9% of the area. And if you look at these pictures too, like ask yourself if it makes sense. Like, does this look like about 9% of the whole area? Yeah, it looks about right to me. Like on this one, did it look like it was about half or 60%, close to 60% of the area? Yeah, looks about like that to me. Okay, and then on the last one, we didn't talk about how to do this one, so I wanted to see if you guys could figure it out. So we know how to do the left tail here, and then what about this right tail over here? So it's the same z-score, but one is positive and one is negative. And you can use the fact that this distribution curve is symmetrical. So if you know how big the left tail is, it's the same size for the right tail, so you can just double it. Okay, so I'm going to look up the table value, the CDF or the area to the left of this z-score, negative 1.25. I don't know why these all end with 5s. Just scroll over here, negative 1.2. Okay, so I'm in this row here. Let's see, 0, 1, 2, 3, 4, 5. I think it should be this one. Let me double check. Yes, that's under the 0.05 column. So 1056. 1056. 1056. Okay, so that is the area that I'm getting for the left tail. And then I'm just going to double that. So I'm going to do 2 times 0.1056. And that is 0.2112. Okay, so that's it for the ones that are already sketched for you guys. And now we'll do some applied problems where you have to find the z-scores and do the sketches yourself. Okay, so while analyzing streaming data for her new album, Sailor Twift notices that the length of time that people listen before skipping any track is approximately normally distributed, with mean 142 seconds and standard deviation 28 seconds. Okay, I'm sure you guys are all big Sailor Twift fans. What percentage of people listen for less than 2 minutes? 120 seconds. Okay, so basically what this problem is saying is that if we were to make a histogram of the time that people listen to her songs, that it would look like this shape. And then what we do when we convert to z-scores, instead of using the original values like 120 or 180, is by converting to z-scores, then we basically make the real histogram look like this histogram, which is called the standard normal one. So all of the normal data, if you convert it to z-scores, basically has the same histogram. And then we have that, so we don't have to have a whole bunch of different sheets. We can just have this one sheet that has all the values in it, and it works for any distribution once you convert it to z-scores. Okay, so that's why we got to convert to z-scores first. So we're going to take these cutoff times like 2 minutes or 3 minutes for this one, convert those to z-scores, and then we're going to look at the areas between them, or to the left of them, or to the right of them. All right, so what percentage of people listen for less than 2 minutes? So I'm doing a less than type. That means I'm doing a left tail. So I want to look at all of the data less than some particular z-score. But I need to find that z-score. Okay, so I'm going to use my z formula. So my formula is data minus mean divided by standard deviation. I just have this memorized at this point. You can look it up on the top of the sheet here. Okay, so this is how far above the mean the data value is. So the mean and the standard deviation are in seconds, so we need to use seconds as well for our data. So I'm doing 120 seconds, and then I'm subtracting the mean. This is going to tell me how far above the mean this data value is. And it's not actually above, it's below, but that's going to be why it'll come out to be negative. Okay, and then on the bottom, I'm dividing by standard deviations to see how many standard deviations this is. Okay. So, and put this in a calculator, round to 2 decimal places. I'm getting negative 0.79 for my z-score. Okay, now let me show you how to do a sketch. I'm going to do like a really kind of ugly looking thumb sketch probably. You guys can see my wonderful thumb drawing skills that I'm so proud of. Okay. All right. Let's do it in purple so I at least feel enthusiastic about it. Okay, so here's my standard normal curve. It has a line under it. It has a hump. Kind of looks like a bell. That's good enough. Okay, the mean is in the middle here. That's the 0 z-score. So my z-score is to the left of it, so I'm going to put my z-score here. So that is z equals negative 0.79. That's a thumb 9, sorry about that. And then I want to know what percentage of people have a z-score that is less than that. So I'm looking for this part of the distribution. Okay, I want to know what is the area here. All right, so that's just going to be one value from the table. I can just look up that z-score, and that table value will correspond to that area to the left of it. So let's go ahead and do that. Okay, so what I'm looking for here is I'm looking for the CDF table value of negative 0.79. And let's go ahead and find it. So negative 0.7, and then it should be the last one in this row over here. So it should be, let me just make sure. Yeah, 0.9 is the last place. And it is 0.2148. 0.2148, 2148. Okay. So that is the percentage. And since it asked as a percentage, we should answer as a percentage. So I'm going to write this as a percentage. This is 21.48%. Okay. So next question, what percentage of people listen for 2 to 3 minutes? So 120 to 180 seconds. Okay, so I already have the first z-score. So I have my z1 from the last question, and it was negative 0.79. And now I need to get my z2 from this part of the question. So that's going to be for 3 minutes. So I am going to do 3 minutes, 180 seconds minus the mean, divide by the standard deviation, and round this to 2 decimal places. So I got 1.36. And now I'm going to get, because I want a between area, I'm going to look up the CDF for both of these, table value for both of them. I already have one. I'm going to look up the other one, and then I'm going to subtract the, Microsoft is so silly. I'm going to subtract the larger one minus the smaller one. Okay. So let me just type in here what I'm doing. So I'm documenting my work. Okay, 1.36. Turn to the positive side. 1.3, and it's the one under the 0.06 here, so that is 0.9131. 9131. Okay, and now I'm going to do larger one minus smaller one. So I'm starting with an area that's too big, and I'm trimming it off to leave me just the area that I want. And put that in a calculator. Okay, I'm getting 0.6983, and I'm going to write that as a percentage because that's what I was asked for. Okay. So we got that 21% of people listen for less than 2 minutes, about 70% for 2 to 3 minutes. So I think you can already tell it's going to be like close to 10% that listen for longer than that, because that's everybody else. And let me go ahead and actually sketch this one because I forgot to do it. So another beautiful thumb drawing. I won't make you watch me. It's a work of art. Okay. Work of art. I'm gonna frame that, put it on my wall. Okay. Let's do the last part. Or the second, well, third to last part, I guess. I put a lot of parts on here. All right, what percentage of people listen for more than 3 minutes? So now I actually have all the numbers that I need right now. I just need to figure out how to use them, and doing this sketch can actually help me do that. So let me go ahead and do the sketch. Maybe I will make you watch this time. So I'm looking for more than 3 minutes, and I know the z-score for 3 minutes was 1.36. Okay, and so anybody that listens longer than that would have a larger z-score. Okay, so they'll be up here. So I want to know what percentage of people have the z-scores in that region right there, and that is given by the area under this curve. All right, so I actually already know the area that was to the left here, and it was this number right here. That is that white area right there. So the area to the left of 1.36 is that 91.31% area. So if I want the opposite of that, I want the area that's to the right, not to the left, I'm going to do 1 minus that. Okay, so when you want the right tail area, you just do 1 minus the left tail. So do 1 minus 0.9131, and that's going to be 0.0869, and I'm going to convert to a percentage because I was asked for a percentage. Okay, so parts D and E are a little bit, again, asking you to do something I didn't actually necessarily teach you, but I want to see if you can do it, if you can reason it out. So a certain Twifty claims that she listens for longer than 99% of other listeners. What z-score has 99% of the area to its left? So it didn't ask me to draw a picture, but you could draw one if you wanted to. You're looking for... Okay, so another work of art here. I'm looking for like, what is this z-score right here? Question mark, that has 99% of the area to its left. All right, so instead of having the z-score and looking up the area, I have the z-score, I have the area and I want to know the z-score. Okay, so I want to use the table backwards, basically. So these numbers in here, these are the areas, and I have an area, 99%, and I want to figure out what z-score gives me that area. Okay, so let's see if we can find 99% in here. Maybe it's in here, maybe it's not in here. I don't know. Let's see. 99%. A lot of these are really close to 99. Let's see. 99.09, 09, 06, 04, 01. Okay, so I think it's 99 exactly percent would be between these two. And I think the one that's closer is this one. So I'm going to go with that one. And what z-score does that correspond to? It's in the 2.3 row, and it's in the 3 column for the second decimal. So 2.33 is the z-score that is closest to giving me 99%. Okay, so I'm looking at approximately 2.33 for the z-score. All right, and then part E is convert that z-score from part D into a data value. How long does the Twifty listen to the album before skipping? Okay, so I'm taking this z-score and I'm using my formula to convert it into a data value, which is this. So you start at the mean and you go up by z standard deviations. Okay, and I was given the mean and the standard deviations. The mean is 142, standard deviation is 28. Okay, so we just put those in the formula here. X equals mu plus c sigma. Mu is 142, z is 2.33, sigma is 28. 28? 28. Okay, and I'm going to put that into a calculator. And I'm getting 207.24, or we could round that to 207, I guess. Right, so that's what, 180 plus 27, about 3.5 minutes. So if a Twifty were to listen to the album for 207 seconds, that before skipping, that would be longer than 99% of other listeners. Oh, I put this in the wrong place. Sorry, it's supposed to be down here. All right. So that's it for Sailor Twift. And now let's look at some other data. Okay, so this is taken from my class survey data from all of my stats classes that I've been compiling. So the heights of my male and female students are both approximately normally distributed. Not if you put them together, but if you do them separately, they are. So the means for the male and the female are here, and their standard deviations are here as well, and these are in inches. Okay, I would like to ask about you guys and like have you guys do your own heights, but just like for the sake of giving you a set thing that you could try to do and, you know, check with your friends, like, did we all get the same answer? I decided to use my height and my sister's height and my dad's height. So here we go. You're going to find out a lot about my family. I am 5'3". What percentage of the female students are shorter than me? So we're going to sketch the area and we're going to label the z-score, and then we'll look it up in the table. Okay, so firstly, my height is, so the x, or the data value here, is we need to convert to feet. We need to convert from feet and inches into just inches. So we're multiplying my feet by 12, and then we're adding on that extra 3 inches. So this is going to be 63 inches for me. And then we're going to convert that to a z-score using the formula, data minus mean over standard deviation. Okay, so we're doing 63 minus the mean is, okay, so I'm doing this for female students because I'm female. So minus female mean, and then divide by female standard deviation, 2.9. And let's see what we get. I'm going to round to 2 decimal places as usual. I'm getting negative 0.66. So now let me make you another beautiful thumb drawing. Okay, there it is. And now I'm looking for female students that are shorter than me, so that's why I colored in the region with z-scores that would be less than my z-score. Okay, so if you are shorter than me, then you have an even smaller z-score than that. Okay, and now what percentage actually is that? I need to find this area using my table. So here we go to the table again. Negative 0.6. And it goes 0, 1, 2, 3, 4, 5, 6. I think this is the right column. Let me double check. Yeah. Okay. So I'm getting 0.2546, 2546, 2546, 2546. Okay. So I was asked for a percentage, so I'm just going to convert this to a percentage. And there we go. So I am only taller than about a quarter of the female students, which must mean that I'm shorter than 3/4 of my female students. Okay. Now my sister, let's see where she's at. So she has the glory of being 5'6". So we're going to find out what percentage of female students have heights between my height and my sister's height. So now I have the z-score. I have one of the z-scores and one of the CDFs, and I need to go ahead and get the other z-score and CDF. So my z1 from the last part is 63, and then I also have the CDF from that. Oh, sorry, not 63. That was the x value. It's negative 0.66, and then the CDF from that, negative 0.66. You don't have to copy this down here every time, but I'm just trying to do it in a way that makes sense to you guys, so you see all my work here. So for my z2 then, I'm going to use my sister's height. So let's see, 5'6" should be 66 minus the mean of 64.9. So she's got a positive z-score. I can already see that. Divide by the standard deviation. Okay, so her z-score is 0.38. And then I'm going to go ahead and look up the CDF or the table area for that. Okay, 0.38. Here it is. 0.6480. And now what I'm going to do is, because I want, and I should do the sketch at this point too, I want the area between these two z-scores. So I'm going to subtract the larger area minus the smaller one. And I'll make a sketch as well. Okay, so here's my thumb drawing. My thumb's got a lot steadier this time, so my skills have improved. All right, so now what I'm doing is I'm subtracting the larger area, 6480, minus the smaller one, 0.2546, and that is going to give me the percentage, or the area that is between those two z-scores. So I am getting about 40%, 39.34% to be specific. All right. So now for the last part is about the male students and my dad. So my dad is, or was, 6'4". So what percentage of my male students would have been taller than him? All right. So 6'4", 6 feet is 72 inches, and then another 4 inches should be 76 inches. So that's going to be the data value. And then for the z-score, we're always doing data value minus the mean, divide by standard deviation. So we're going to do 76, and now for the mean and the standard deviation, we're using the men's values. Okay, so we're going to use 71.2 for the mean, and we're going to use 3.1 for the standard deviation. So I think he's got a pretty big z-score here. Okay, so I'm getting 1.55. And then for my sketch, which area am I actually trying to find? So I'm looking for male students taller than him. So taller would mean they would have a z-score that would be greater than this. So I'm looking for a right tail. Oh, that's weird. My thumb got shaky again. All right, so how do we get the area to the right of a z-score? Well, we know how to get the area to the left of a z-score, right? And if you want the area to the right, you are looking for the opposite area, so you're going to do 1 minus that, because the area under the whole curve is 1. So I'm going to do 1 minus whatever this table value is. Let's see, 1.55, 1.55. It is 0.9394. 9394. Okay. All right, so I'm getting 0.0606, or 6.06% of my male students would have been taller than my dad. All right, so that is it for this homework. Hope it makes sense to you, and I will see you in class.